In this module, you'll learn to use Siklu's Link Budget Calculator, or LBC. The LBC will allow you to choose the right product for your network to calculate the expected receive signal and the link's expected availability. The Link Budget Calculator is an easy-to-use online tool that provides link performance calculation. To access it, point your browser to lbc.siklu.com. If you don't have these, click on Register to create a new account. You'll be asked to complete a very short questionnaire, after which an activation email will be sent to you automatically. Follow the link in that email and your account will be ready to use. Please contact Siklu support if you encounter any difficulties or if you don't receive an activation email. Let's begin. As rain intensity varies based on geographical location, the first step is to choose the link's location. You can do this by choosing a rain zone, entering specific rain intensity, selecting a city, or entering exact latitude and longitude coordinates. We recommend indicating location based on city or coordinates, as these options make use of the latest rain prediction models and provide more accurate results. The most straightforward way is to select a city from the drop-down menu. If you can't find your city, select the one closest to it. Alternatively, enter the coordinates of the sites comprising the link. Use decimal notation with negative longitude designating the Western Hemisphere. The link length is automatically calculated and displayed. You can override this automatic calculation by clicking Same as Antenna A next to Antenna B and then manually typing in the correct link length. That's it for location. The second step of the process is to fill in the link parameters. Select the product you intend to use. The LBC supports all currently available product options and is updated regularly. Set the channel width you plan to use. If unsure, use 500 MHz, as narrower channels reduce the link's throughput. Next, choose the center frequency. It's not really necessary to bother selecting one when using E-band radios, as performance is the same across the band. However, in V-band, do make sure you select the frequency you intend for the link, because that will make a significant difference in terms of the attenuation due to oxygen. In this case, the loss due to oxygen is shown as a function of the selected frequency. The drop-down menu presents the available antennas for the selected product, together with size and gain. Use larger antennas if the predicted performance doesn't meet your needs. Remember to check local regulation, as the 0.5-foot antenna in E-band is not allowed in certain countries, such as the USA and Australia, to name a few. When it comes to polarization, Use vertical whenever you can, as it has a small performance advantage over horizontal polarization. Next is the transmit power, which is automatically set to the highest possible power level for the chosen product. There is normally no reason to change this. User spare is additional loss, which is taken into account in the calculation. For example, to account for imperfect antenna alignment, tolerance in transmit power, and other unexpected sources of loss, we recommend using 2 decibels. Last is the capacity ratio, applicable for products operating in TDD only. For those products identified by T or TX suffix, capacity is displayed as aggregate. That is the total throughput of both directions of transmission, or else separately with either symmetric or asymmetric configuration. We are now finally ready to select the type of calculation required and run it. The LBC offers 3 types of calculations. The first, and most commonly used, assumes that you know the product of choice and the link length. It then proceeds to perform a detailed calculation for this scenario. As an example, we'll be looking at a 2.5 kilometer EtherHertz 1200 FX link with 31 centimeter antennas located in London, England. You see the expected RSSI, or received level. That's the value you should aim for when aligning the antennas. If you indicated the link's location by selecting a city or entering coordinates, the expected availability and downtime of each modulation profile will be presented. As expected, lower modulation profiles with corresponding lower throughputs will have improved availability. Check the lowest modulation profile to work out the absolute link availability. In our case, 99.997%, which is equivalent to 16 minutes of total downtime per year. At the bottom of the calculation page, you will see the maximum throughput of the link at the industry standard availability thresholds, ranging from 99% to 99.999%. The second type of calculation is length range, which calculates performance over a range of link lengths. It's useful when trying to get a general idea of the selected product's performance as a function of the link length. Tick the length range option, and the LBC will calculate for all lengths specified between the start and end values at the designated steps. In this example, every 100 meters, from 1,000 meters all the way to 3,000 meters. This type of calculation produces a very useful yet much simpler output, which consists of the expected throughput per industry standard link availability per link length. For example, here's our SmartHaul 1200 FX link with 31 centimeter antennas in London, with a link length calculation from 2 kilometers to 3 kilometers every 100 meters. Looking at this table, one can see, for instance, that the link is predicted to provide 1000 megabits per second at 99.95%, up to 2.6 kilometers, after which the availability for 1000 megabits per second drops to 99.9%. So, what do these results tell us? Is this link's performance acceptable? Will it work? Or should a higher power product be selected, or larger antennas used? This depends, of course, on the required throughput, performance criteria in your network, and your SLA contract with your customer. We recommend the following performance criteria, which our customers most commonly use. Availability of 99.95% or 3.5 nines for the required throughput, while maintaining minimum 99.995% or 4.5 nines for the lowest modulation, or absolute link-up time. In this example, if the required throughput is 1000 megabits per second, we see that we can extend it up 2,600 meters. However, if the required throughput is only 700 megabits per second, the maximum length is increased to 2,800 meters, as the link manages to maintain an absolute link-up availability of 99.995%. Now for the 8010 FX example with 65 centimeter antennas located in London, England. In this example, if the required throughput is 10 gigabits per second, we see that we can extend it up 3,500 meters. We can see that the link can provide 10 gigabits per second at 99.95% availability, while maintaining an absolute link-up availability of 99.995%. When it comes to multi-hole point-to-multipoint system, you will need to select first the terminal used, the T200 or the compact T201 that has lower gain and therefore applicable for shorter distances. Note that stated throughput refers to the max aggregated bandwidth of the base unit and terminal units. We recommend determining the max link length based on minimum modulation of MCS4 or 900 megabits per second at 99.95% when taking into consideration 1 decibel user spare and while maintaining an absolute link-up availability of 99.995%. In this example, in San Francisco, US, it's 280 meters. The third type of calculation is useful when you're unsure of which product and antenna to use and wish to get a bird's eye view of the performance of all possible combinations at a given link length. Tick the product range option and indicate whether you wish to consider E-band products, V-band products, or both. Please note that due to the large number of calculations, this option may take a little longer to complete. The product range calculation shows the expected throughput for each of Siklu's products and antenna options at the selected channel width. For example, suppose you'd like to deploy a 2.5 kilometer link in London, but are not sure which product will give you what throughput at what availability. This output will immediately show you what to expect. That's it. Now it's your turn to run a few examples on your own. Good luck!